These are squash blocks. They're using the same OSB wood, and that's fine, as what they have on the outside. Below these squash blocks, we have a beam underneath there. Above it, we're going to have a load-bearing wall above that. Because it's a beam underneath and a load-bearing wall above, that's that pinch point that I was talking about, because of which we need to have these squash blocks, and I've seen people use 2x4s, which is just fine. You know, here they just used probably some scrap rim boards that they had going around the outside, or box joist boards going around the outside, and they used that for their squash blocks. Totally acceptable, all right? Same thing. Here we're just looking at 2x4s being used. Again, we probably have a load-bearing point up above it. One on each side. You know, I mean, you're supposed to be there. Sometimes you can't fit it in there because of utilities, gas, plumbing, heating, electric, whatever. But we should have one on each side. And I'm not going to let somebody else, you know, again, it's not my problem that I can't fit it in there. All right? And I don't want to be the guy that says it's okay. Let somebody else do that. All right. Here we're looking at a foundation wall. We got exterior insulation on the concrete foundation wall. I like all this stuff. You can see where the exterior of the concrete is sticking out further. That's going to be for a brick ledge. We don't have that concrete sticking out here on the sides because we're going to have siding over here. So they're probably only going to be putting brick in the front, or probably just around this area here, because this section does not look like it has a brick ledge on it either. All right, so we're going to have a brick veneer over here. Then we put all our I-joist in, and we probably have beams underneath here holding the support, and you can see all the squash blocks in there as well. All right, the OSB, this is purchased from TJI or whoever the manufacturer is, and you know, again, that's our supports around the outside, so I don't have to have squash blocks on the perimeter walls. I only need them over beams and underneath load-bearing walls. All right. Again, close up, they missed a little bit with the anchor bolts. So these anchor bolts here, they're going to be broken off and taken off. But that's what was supposed to be holding down this sill plate underneath here. Obviously, that's a whoops, all right, that has happened. So go back with the trusses again. We'll zip through this pretty quick. We got our top chord, we got our bottom chord, all our middle pieces inside are going to be our web members in there. We hold all those pieces of lumber together with what's called gusset plates on there. Those gusset plates can be wood or steel. Most of the time what we're going to see is going to be steel. It's a manufactured process, and then they deliver the trusses to the site. All right. Trusses should be installed on their bearing points. This is a good spot here. This piece of lumber, and bearing points have to be solid from top to bottom. Now, they do make trusses that are bottom bearing, and they do make trusses that are top bearing. All right. Either way is acceptable. But if it's a bottom bearing truss, then I have to have solid lumber. I can't put a load bearing wall right up underneath here, or maybe right underneath here. It's got to have solid lumber underneath it. Now, if for some reason I need to have a load bearing wall, again, they have made modifications. You can do this to the truss. They could solidify all this stuff up in there. So there are repairs that can happen. It's not the end of the world. All right. Same thing with the I-joist. Top chord, bottom chord, middle is the web. We kind of chatted on that already. We talked about the web stiffeners. If we're going to have joist hangers coming across, we talked about the web stiffeners holding that up. Squash blocks, basically, they make a rectangle out of everything, or we're going to have them on either side. Only have to be located whenever it's at a pinch point. So if I got pressure from below and pressure from above, that's my pinch point that comes in there. Okay. Here's another view of an actual one. This piece was kind of left over or cut on here just so we could see what it looks like. Here we were in the basement and we looked above, and that's a load bearing wall there, and there's no squash blocks. All right. So before we call things out that there's no squash blocks, we went above to see if there's a load bearing wall from above, and it wasn't. It was all open, or it was off to the side. If that's the case, then we don't have to have squash blocks at these locations. All right. And again, we see our squash blocks. The rim joist is the squash block, so we don't have to have them installed there as well. I'm going to skip over the brick and the brick veneer section here. This is repetitive. We did this on the exterior one. So if you want to see this and talk about it, I'm sorry, but you're going to have to watch the exterior section. Thank you for bearing with me. And again, this is all talking about brick, true brick, and brick veneer, and different things to hold stuff together. Alright, so now we're going to get to the roof, and that's going to be the end of stuff once we finish with this section here. I would like you to be able to tell the difference between a truss and a rafter. And if you're shaking your head, come on, how basic are we going to get? I'm sorry, but there are going to be people that don't know the difference, all right? I'd also like to use the proper terminology when you're identifying the different types of rafters and the different trusses and the different parts of each when it comes with it, all right? The term rafter or stick frame construction, that's our upper left that we're looking at here. These are going to be, whether they're 2x6s, 8s, 10s, 12s, depends on the length and whatever the engineer or architect have designed or planned for it to be. The term rafter is going to be used when the rafter actually sits on the top plate or on the wall of the structure, and it reaches either the other rafter on the opposing side or the ridge board or ridge beam at the top. If it makes it all the way to the top or the bottom and it touches at both ends, it's called a rafter. If it does not make it to both the top and the bottom, then it's called a jack. So this one here is known as the hip rafter. If it's on an outside corner, it's a hip. An inside corner, it's a valley. Because it touches the top and the bottom, it's a valley rafter or a hip rafter. This one is part of the hip, but it doesn't touch both sides, so this is a hip jack. Same thing with this one over here. It'll touch the top plate, but it won't make it to the, it'll touch the rim joist. Boy, I'm having trouble with my words and pulling them out of there. It'll touch the ridge board at the very top, but it doesn't make it to the top plate down low. It makes it to the valley rafter. So because of which, it's called the valley jack that comes in here. So rafters make it all the way up to the ridge board and the top plate. Jacks do not. If it's part of an outside turn, it's a hip. If it's part of an inside turn, it's a valley. Plain and simple. I'd like you to know the difference between a roof joist and a roof rafter, or just plain rafter. 212 is our magic number, all right? Anything 212 or less is considered a flat roof, so if we have a flat roof on this thing, it's not really going to be a rafter, it's going to be a roof joist that comes in there. Anything over 212 is going to be a rafter, all right? This goes back to showing kind of what I explained earlier, talking about the jacks. The full lane up and down here is a rafter. A common rafter is going straight and not part of the hip or the valley, and where a hip jack is part of the hip and the valley. All right. So realize we're making triangles out of things when we're building roofs and houses, where it comes with it. And as long as that triangle is intact, we're good. All right. But in order for that sag that we're seeing up here to happen, if this is going to drop down, then those walls have to be pushed out. All right. So all we have to do to maintain our triangle, usually our ceiling joist will do this, and that's what goes across here. That's going to keep my walls from bowing out. As long as I prevent my walls from bowing out, we're golden. All right. But if I do let that happen, then it's going to be a problem. What typically happens for ceiling joist, you're going to see we'll get usually around like 5 or 6 nails in here so we get a lot of stress support. Then they're going to overlap and let them run wild in here. And then again, at least 5 nails or more holding these things together. That's one option. Narrower, smaller houses, they may go with the continuous board. Sometimes people are going to want to keep these things lined up for whatever reason. Usually you're going to have a wall in between there, so it doesn't really come into play so much. But nonetheless, if they do, then they'll butt these things, B-U-T-T, them up next to each other. And they're going to use the plywood decking above here as more of a gusset plate to keep those things from coming apart. All right. So if I butt it, I need to have some sort of a gusset on top of that. And that's what the plywood flooring from above does. And this drawing kind of shows what I was trying to explain earlier. Single piece of lumber going all the way across. But we need to make sure that we're secured to our rafters at both ends on there. 412, and I don't see this done too much. It's actually pretty easy, or makes construction much easier to put the ridge board up on there. But you don't have to have one. So that's tops in alignment, all right? Whereas a ridge beam is actually load supporting. Now in this situation, notice that our ceiling joists don't go side to side, all right? In fact, it's actually open there. So what I'm doing on the other hand is I'm preventing this top from going down. As long as I prevent that top from going down, then that in itself is going to prevent my walls from bowing out, all right? So that's a ridge beam. A ridge beam is load supporting, where a ridge board is more of a nailing point to it, all right? Rafter sags, if it's too thin, heavy snow loads, maybe there's a lot of roofs on it, something where it's overweighting, you know, we want to avoid the sag. We have a few different methods to go ahead and avoiding the sag on there, and making them stronger, you know, common sense stuff here. Splits, splices, damages, warping, concentrated load we talked about, wood rot, insect damage, everything else. Those are all things that we're going to be looking for when we're in the attic. So different methods that we're going to do to prevent that rafter sag is, and what's common in our neck of the woods here around Chicago, is something called collar ties. So typically they're going to be installed every 4 feet, so we don't have to have one on every roof. They're supposed to be halfway up between the top of the rafter and the top plate or the bottom of the rafter, and it's supposed to go all the way across. We should be having a lateral support on here too that will I might have lost signal. I think I lost signal on here, so I'm going to stop it and start it again. Yeah, I did.